Probability of compound events means that the event that you're trying to find the probability of could essentially compound on itself. So what that means is when you're finding the probability of an event, sometimes that event or events are exclusive, which means there's no overlapping involved and it's just one or the other. Sometimes one or the other event has overlapping, and then if there is that overlapping, we need to address that when finding the probability. So the overlapping is what I tried to sort of show in this first box, and the mutually exclusive would be in the second box. So you can sort of see with the exclusive probability, A and B don't overlap, they just are two separate things. Whereas the first one, there is an overlap there in the middle where those two things are sort of the same. So when you guys are finding the probability, if they are overlapping, that's the first box here. So if you do have two things that are overlapping, what's going to happen is you're going to find the probability of A or B together. You're going to add them up, one or the other, A or B, but you have to subtract the portion where they are both A and B, because we want one or the other. So we want to exclude the overlap because we just want A or B. We don't want A and B, we want one or the other. Now the other option is if they are mutually exclusive. If they're mutually exclusive, there is no overlap, so there actually is nothing to subtract. So in that case, to find the probability of A or B, you just simply add the probability of A or B. Nothing to subtract because there's no overlap. So if we look at an example, again, looking at your deck of cards, a card is randomly selected from a standard deck of 52 cards. So what's the probability that it is an ace or a face card? So remember, ace cards do not count as face. Face cards are the jacks, queens, and kings. So if we're trying to find the probability of an ace or a face card, we just add them up. So how many aces are there in a deck? And this is probability, remember, so it's out of the total. So there are 4 aces in the deck, and there are a total of 12 face cards. So at no point in time can an ace card be a face card. So in this case, they would be exclusive, and there's no overlap there to subtract. So all we do when we're adding and subtracting fractions, we keep that denominator and add the numerator. So 4 plus 12 gives us 16 out of 52. Again, I'm not overly concerned about you guys reducing it because I like to have the original fraction there. But if you did reduce it, it would reduce to, divide both by 4, 4/13. You could also write it as a percentage, which would be 31%. So if there is overlap, you would need to subtract that overlap because we want one or the other. We want to exclude when they are both. So if you look at number 2, a card is randomly selected from a standard deck. What's the probability that it is a heart or a face card? So we want the probability of them both. So probability of a heart or a face card. And then you guys just want to count the number of, or if you just know, number of heart cards, number of face cards. So heart cards, there are 13. And there are 12 face cards. So if you're looking at your deck, I'm going to go back to my deck of cards. So we have the 13 heart cards right here. Now mine don't show faces, but, and you have your 12 face cards. So of those face cards and the 13 heart cards, the ones that are both are the Jack, Queen, King, and Hearts. So the overlap, that's not just one or the other, they're actually both, are those three cards. So the overlap we have to subtract is 3 out of 52. And those would be the heart and face cards. So 13 plus 12 minus 3. So 13 plus 12 is 25, minus 3 is 22 out of 52. So that would be the probability of picking a face card or a heart card. Again, you don't have to reduce it. It would reduce to 11/26 though. Just divide both of them by 2, which would be 42%. 42% probability of choosing a heart card or a face card in a deck. So you guys just want to pay attention to if there's overlap when you're finding the probability. We just haven't done any yet where there was overlap, so it's sort of new. So if you keep going here, I've crossed out number 3, so number 4 is actually your number 3. It says in a survey of 200 pet owners, so 200 total people surveyed, people that own pets. 103 owned dogs, 88 owned cats, 25 owned birds, and 18 owned reptiles. So it has 3 parts, A, B, and C. It says none of the respondents for A owned a cat and a bird. So there's no overlap with cat and bird owners. So what is the probability that they owned a cat or a bird? So, probability of a cat or a bird being your pet, we wouldn't know if any person owned both of them. So they have to tell us that there's no overlap. So since there's no overlap that we would have to subtract, we would just want to add the cat owners plus the bird owners. So 88 out of 200 plus 25. Out of 200. So 88 plus 25, 113 out of 200, which is just a little over half. So if you guys divide that, it would be 57%. Okay, so B says of the respondents, it's now telling you that, okay, 52 of them did actually both own a cat and a dog. So there is overlap there with cat and dog owners. So what's the probability then that they own just a cat or a dog? So, same thing, probability of a cat and now a dog owner or a dog owner. We're going to add both the cat and dog totals up. So 103 plus 88. So 88 cat owners plus the 103. So that's cat, that's dog. But we need to subtract the 52 people that own both because we just want to know the probability of selecting someone that owns one or the other. So 88 plus 103 minus 52 gives us 139 out of 200 people that own a dog or a cat only. If you divide that, you get 70%. So when you're trying to find the probability of one thing or the other, you're always adding them both because it's one or the other, but just pay attention if there's overlap there to get rid of that portion. So C says of the respondents, 119 owned a dog or a reptile. So it's telling you the probability here, and it wants you to find what's the probability that they owned a dog and a reptile. So it wants you to find the overlap here. That's what this is. A dog and a reptile is the overlap. So the probability of a dog or a reptile is going to be the both of them added up. So dog was 103 and reptiles were 18. So 103 out of 200 plus 18 for the reptile owners out of 200. We're trying to find the number of people that own both. So we're trying to find that overlap. But we know that it equals 119. So if we do this math, 103 plus 18 is 121. So either in your head or you can actually solve for it. 121 minus what would be 119. So 121 minus 2 gives you 119. So 2 people only owned a dog and a reptile. That was the overlap there. So compounding probability means we're finding one thing or the other. We're finding possibility of more than one thing. So not just blue or not just the probability of a 3. It's more than one thing, but we need to make sure we're getting one or that other thing, not when they are both. That's really it. So go ahead and try the practice problems on the next page.